Concavity has a simple definition. We've covered it previously, and basically, if f prime prime, or the second derivative, is greater than 0, then we say it is concave up. If the second derivative is less than 0, then we say it is concave down. Or in other words, when f prime increases, we have concave up. So basically, the slope increases as x increases, giving this upward curving shape. So think concave curving upwards. Similarly, when f prime decreases, the derivative decreases as x increases. This gives a downward curving concave down scenario. So think which way it curves. Does it curve up or does it curve down? That's the intuition. Now, the second derivative test is you can apply it when you know that it's twice differentiable and you have a point where the derivative is 0. Now, if f prime prime is less than 0, we have a downward curving graph. And at the point where the derivative is 0, that is where we have the local maximum. That is because f prime prime is less than 0, the slopes afterwards would be less than 0, and the slopes before it would be greater than 0. So essentially, you could convert this to a sort of first derivative test case where you have a local maximum. Similarly, if you have f prime prime is greater than 0, then you have this upward curving curve. And at the point where you have the derivative 0, you would have a local minimum. So basically, you would just need twice differentiable, derivative is 0, and the sign of the second derivative to tell if a point is a maximum or a local minimum. So that is the second derivative test. Here, let's go back to concavity, and we need to introduce a concept called point of inflection. Point of inflection. And AP defines it as a point where concavity changes, or basically that the sign of f prime prime changes. So the way we identify candidate points is that when f prime prime is equal to 0, then like in the first derivative test, we're going to examine if f prime prime changes sign at that point. So we're gonna try some exercises in the next video, and it will involve the point of inflection. So there are two main parts to 5.6 and 5.7, the second derivative test and points of inflection.